Hello everyone, in this session we shall continue with the problems on equilibrium of concurrent force system. In the last session we discussed about the problems on rollers. So in this session we shall discuss about the problems on the cables. So let us take up the first problem, so which states that figure shows a system of cables in equilibrium condition under the two vertical loads, that is 300 Newton and 500 Newton. So we need to determine the force developed in the different segments. So this is a given problem which consists of a system of cables and which are in equilibrium, under which there are two vertical loads, and first one is 300 Newton and 500 Newton. We need to determine the forces developed in different segments. So this figure consists of two segments, and at B there is a vertical load and 3 cables, and at C one vertical load and 2 cables. We know that the cables will always going to produce a tensile force. So this at joint B there is a cable AB. The tensile force will going to develop in outward direction if you consider any of the joints here, either A or B. So this can be called as TAB. Similarly, at cable BD, this is TBD. At cable BC, it is TBC. At cable CE, this is TC. So if you consider this joint, the tension force in this cable should be taken in this direction. If you consider joint C, you should consider the tension in the cable BC in this direction. So let us decide which segment we should consider first. So if you consider the segment B, there are 3 tension forces and another one is a vertical load, and the 3 tensions are unknown. So when it is concurrent force system, we have only 2 equilibrium conditions. One is sigma Fx is equal to 0 and sigma Fy is equal to 0. And here there are 3 unknowns, so we cannot solve using the equilibrium conditions. And if you consider joint C, there are 3 forces, out of which 2 are the tension and another one is a vertical load. So when there are 3 concurrent forces, we can apply Lamis theorem and we can solve for the unknowns. So after knowing the tensile force in the string BC will remain same for joint B also, then only 2 unknowns will going to remain. So we can apply the equilibrium condition at joint B. You can also apply equilibrium condition for joint C apart from Lamis theorem. So let us consider the joint C. First write the free body diagram. This angle is 60 degree. Next TBC, and the inclination angle of which is through alternate angles, this is 30 degree. So in order to apply Lamis theorem, we need to know the angle between each of the forces. So this will remain as 90 degree, this is also 90 degree. So the total angle is 150 and 120, and this angle is, so total it is 180, and here it is given that it is 60 degree and 30 degree, 60 plus 30 it is 90 degree, and the remaining angle will be 90 degree. So apply Lam's theorem. So TCE divided by sine of angle between other two. So this is the considered force. So the angle will be sine 120. Second one, it is TBC, and sine of angle between other two is 150, which is equal to, third force is 500 divided by the angle between other two is 90, that is sine 90. So TCE is equal to 500 divided by sine 90 multiplied by sine 120, and TBC is equal to 500 divided by sine 90 multiplied by sine 150. So on solving this, we will going to get the value of TCE as 433.01 Newton, because the force is given in Newton, and TBC as 250 Newton. Now we shall consider joint B. Now we got the value of TBC and TCE. So this TBC value will remain same when you consider joint B. So consider joint B. First write the free body diagram of joint B. 300. There is a vertical tensile force TAB. This is TBD. And TBC, we got the value of TBC as 250 Newton. The angle given is 30 degree, this is 45 degree. So we know that when the forces are inclined, before applying the equilibrium condition, we need to resolve the given inclined forces, right? So on resolving, this will be TBD sine 45, the vertical component, and the horizontal component is TBD cos 45. And there is another force in the fourth quadrant. On resolving, we will going to get the x component as 250 cos 30 and vertical component as 250 sine 30. So now we can apply the equilibrium condition at joint C. So first equilibrium condition is sigma fx is equal to 0, which means that the algebraic sum of all the x components. So consider all the forces on the positive and negative x-axis. So on the positive x-axis there are two forces. One is 250 cos 30 plus TBD cos 45, and on the negative x-axis there is a tensile force AB, which is equal to 0. So here there are two unknowns, one is TBD and TAB. So let us consider this as equation 1. So second equilibrium condition is sigma Fy is equal to 0. So now consider all the forces on the y-axis, both on positive and negative y-axis. On the positive y-axis there is TBD sine 45, and on the negative y-axis 250 sine 30 and the vertical load 300, which is equal to 0. So on solving this, we will going to get the value of TBD as 601.04 Newton. Now substitute the value of TBD in equation 1 and solve. We will going to get the value of TAB. substitute TBD in equation 1, we will going to get the value of TAB, right? So that is 250 cos 30 plus the value of TBD we got is 601.04 cos 45, which is equal to TAB. So that implies TAB is equal to 641.505 Newton. Now we got all the forces at different segments. Now we shall consider the second problem. So second problem states that in the given figure, the portion BC of the string is horizontal and the pulley is frictionless. Determine the tension in different parts of the string and also find the weights W1 and W2. So in the given figure, in the given system of forces, there are two vertical loads W1 and W2 at joint B and C, and there is a frictionless pulley at D, and over which there is a hanging load of magnitude 100 Newton. So when we are discussing about some important points, we got to know about this frictionless pulley. Whenever there is a hanging load, that hanging load will be equal to the tension in the connecting cable. So here the connecting cable is CD, so the tension developed in CD will be is equal to this hanging load due to that pulley is frictionless, which is equal to 100 Newton. And there is a string BC which will going to develop a tensile force TBC, and it should act in outward direction from each of the joints, and at string AB the tension developed will be TAB. So now at each joints there are three forces. You can choose any of the joint and solve easily. So let us consider first, consider joint B. So first write the free body diagram of joint B. So at B there is a vertical load W1 and a tensile force BC and tensile force AB. So the angle between TAB and TBC is given as 120 degree, and this will remain as 90 degree. So the remaining angle will be 60 and this is 90. So the total angle between these two is 150, this is 120 and this is 90 degree. So TBC divided by sine of angle between other two is 150, and TAB divided by the sine of angle between other two is sine 90, which is equal to W1 divided by sine 120. So at this joint there are three unknowns. We cannot equate with three unknowns. Even if one of the force is known, we can solve easily. So let us first consider the joint C. So after solving for joint C, we will consider the joint P. So first consider joint C. So at joint C, first write the free body diagram. At C there is a hanging load W2, tension in the string CD is known, which is equal to 100 Newton, and tension in the string BC. So the angle between these is 135, this is 90, and the remaining angle is this is 45 and this is 90. So the total angle will be 135 degree. Right. So now apply the Lam's theorem, that is TCD, which is equal to 100 divided by sine of angle between other two. So other two forces is TBC and W2, which is 90 degree, which is equal to TBC divided by the angle between other two is 135 sine 135, which is equal to W2 divided by the angle between other two is again 135, that is sine 135 degree. Right. TBC and W2 will be equal because the angle between the other two is same. So which is equal to 100 divided by sine 90 multiplied by sine 135. So on solving this, we will going to get the value of TBC and W2 as 70.710 Newton. So now we got the value of TBC. Now substitute here, which is equal to 70.71 Newton. So here it is 70.71 Newton. Now solve for TAB and W1. So TAB will be equal to 70.71 divided by sine 150 multiplied by sine 90, and W1 will be equal to 70.71 divided by sine 150 multiplied by sine 120. So on solving this, we will going to get the value as for TAB it is 141.42 Newton and W1 is 122.473 Newton. So now we got all the forces in different segments of the given system of forces. So now let us consider the third question. So third problem is determine the angle theta for the system in the strings ABCD in equilibrium. So the given figure is So in the given figure, we need to find out the value of theta, which is nothing but the inclination angle of the tensile force which is developed in the string CD. So when you consider the joint C, we don't know the value of theta and the tensile force in the CD and tension in the string BC and this one. So let me consider joint B. We have a vertical load 20 Newton and the two unknowns, that is tension in the string BC and tension in the string BA. So let us consider joint B. First write the free body diagram. This is tension in the string BC. And tension in the string AB. So the inclination angle of which is through alternate angles, the inclination angle with respect to y-axis is 30 degree. So this is 30 degree, right? Now we need to know the remaining angles in order to apply the Lami's theorem. So if this is 30, this will remain as 60 and this is 90. If this is 50, this is 40 degree and this is 90 degree. So the total angle between these two is 90 plus 30, it is 120, plus 40, it is 160. So the angle between these two remains the same, that is 50 degree, and the angle between these two is 90 plus 60, it is 150. Right. Now apply the Lami's theorem. First force here is TAB divided by the angle between other two forces is 20 Newton and TBC, which is given as 50 degree, that is sine 50, which is equal to second force here is 20 Newton divided by the angle between other two is 160, that is sine 160, which is equal to the third force is TBC divided by the angle between other two is 150, so sine 150. So TAB will be equal to 20 divided by sine 160 multiplied by sine 50, and value of TBC will be equal to 20 divided by sine 160 multiplied by sine 150. So on solving this, we are going to get the value as 44.79 Newton for TAB, and for TBC 29.23 Newton. So now let us consider the next joint, that is joint C. First write the free body diagram at joint C. This is a tension in the string CD. So through alternate angles, again if this is theta, this is also equal to theta. So the angle with respect to the vertical axis is theta, and there is a tension in the string BC. So now we got the value of BC as 29.23 Newton, and the inclination angle of which is equal to, if this is 50, through alternate angles. This is also 50 with respect to vertical axis. Right. Now we shall solve for the value of theta and TCD, right. So we have equilibrium equations, that is sigma fx is equal to 0 and sigma fy is equal to 0. So see, apply sigma fx is equal to 0. Before that, resolve the given force. So this TCD will become, see, the angle of which is given with respect to y axis. So the x component will become TCD sin theta and y component will become TCD cos theta, and resolve the force TBC, which is equal to 29.23, and here also the inclination angle is given with respect to the vertical axis. So 29.23 sin 50, and the vertical component will become 29.23 cos 50. Right. Now consider all the horizontal forces on the x axis, which is equal to TCD sin theta, which is on the positive x axis, and on the negative x axis it is 29.23 sin 50, which is equal to 0. So therefore TCD sin theta will be equal to 29.23 sin 50. So let us keep this as equation 1. So similarly consider sigma fy is equal to 0. Right. So consider all the forces in the vertical axis. So that is TCD cos theta plus 29.23 cos 50, and on the negative axis there is 25 Newton force, which is equal to 0. Right. So now TCD cos theta will be equal to 25 minus 29.23 cos 50. So let us consider this as equation 2. So now if we do equation 1 by 2, so at LHS there is TCD sin theta, and in equation 2 there is TCD cos theta. If we divide equation 1 by 2, TCD and TCD gets cancelled, and sin theta by cos theta will going to give you the tan theta, and you can solve for theta easily. So divide equation 1 by 2, so that TCD sin theta divided by TCD cos theta, which is equal to 29.23 sin 50 divided by 25 minus 29.23 cos 50. Now TCD and TCD gets cancelled, so this will be equal to tan theta, and the value of which will going to give you 3.604. So theta is equal to tan inverse of 3.604. So that implies theta will be equal to 74.49 degree. So now we got the value of theta. Now there is another unknown, that is TCD, right? We need to find out the value of TCD. So now substitute this value of theta in equation 1. or you can also substitute in equation 2. So substitute theta in equation 1 or 2. So on substituting this value, TCD will be equal to 29.23 sine 50 divided by sine of theta is 74.49. So on solving this, we will get the value as 23.23 Newton. Let us consider the fourth problem, which states that figure shows a lamp whose shade has been fixed using two strings. Determine the tension in the string. So the given figure is the weight of which is 15 Newton. So the angle given is 60 degree. So we need to find the tension in the string. So for that, we have two strings, that is BA and BC, and always we know that the cables or the strings will going to develop a tensile force. So let us name this as TBC and this is TBA. In order to find out this inclination angle, first we shall consider here it is 90 degree. So 90 plus 60, it is 150 and the remaining angle will be 30 degree. And again, so here the angle given, that is 45 degree. So through alternate angles, so this angle is also is equal to 45 degree. So now if we consider joint B, we can directly get the values of TBC and TBA. So now let us consider at joint B. First write the free body diagram. So the hanging weight is here, W is equal to 15 Newton. There is a tension in the string BC and tension in the string BA. So the inclination angle of which is, this is 45 and this is 30, this will remain as 90 and this is also 90. So here it is 45 and this is 60. So now the total angle of which is, this is 135 degree and this is 120 degree and this is 105 degree. Right, now apply Lam's theorem, that is TBC divided by the angle between other two is sin 120, which is equal to TBA divided by the angle between other two is 135, that is sin 135, which is equal to the third force is 15, the angle between other two is 105. So TBC will be equal to 15 divided by sin 105 degree multiplied by sin 120 and TBA will be equal to 15 divided by sin 105 multiplied by sin 135. So on solving this, we will going to get the value of TBC and TBA as the tension in the string BC is 13.448 Newton and in TBA is 10.980 Newton. Now let us consider the fifth problem. That is, find the value of W which is required to maintain in equilibrium configuration which is required to maintain the equilibrium configuration as shown in figure. So the given figure is so the hanging weight given is W and here also it is W. So this is theta, this is A, B and this is C. So this is the given figure and here from the given figure the load W is hanging and it is passing over A and B and this pulley at A and B is frictionless. So in the given figure the load W is hanging and it is passing over the frictionless pulleys A and B. So therefore the tension developed in this string AC, the tension developed in this string AC and tension developed in this string CB will be equal to this hanging load. That is, TAC will be equal to W and TCB will also be equal to W. So, again we need to find this inclination for the tensile force developed. So, for that here it is mentioned in both the sides as theta. So, through alternate angles this will be also equal to theta. So, for this theta they have given the opposite side and the adjacent side. So, the total length given is 3 meters. So, up to this center this will remain as 1.5 meters. So, from this triangle we can consider for this theta this as opposite and this as adjacent side. So, that is tan theta will be equal to opposite is 0.5 and the adjacent side is 1.5. So, that theta will be equal to tan inverse of 0.5 divided by 1.5. So, on solving this we will going to get the value of theta as 18.43 degree. So, 18.43 degree. Now, let us consider the joint C. So, at C, so now this theta will be equal to 18.43 degree. So, this theta will be equal to 18.43 degree. First write the free body diagram at C. This is 100 Newton and this is TCB which is equal to W and the inclination angle is theta and this is TAC whose inclination angle is again theta. So, this is 90 degree and this is also equal to 90 degree. So, theta will be equal to now 18.43 degree. So, this is also equal to 18.43 degree. So, the remaining angle will be equal to 143.14 degree because the total angle is 180 minus 18.43 plus 18.43 will going to give you this 143.14 degree. Now, you can apply Lami's theorem, right. So, the total angle between these two is 90 plus 18 is 108.43 degree. So, between these two also it is same, that is 108.43 degree. So, between these two it is 143.14 degree, right. Now, TCB divided by or W divided by sine of 108.43 because the opposite angle is this. Next one, TAC or W will be equal to or directly proportional to sine of angle between other two is again 108.43. The third force is 100 Newton divided by sine of angle between other two is 143.14 degree. So, since the angle between other two forces in this case is same, so TCB is equal to TAC which is equal to W which is equal to 100 divided by sine 143.14 multiplied by sine 108.43. So, on solving this, we will going to get the value of W as 158.15 Newton.